Will humans go extinct? Well, the simple answer is yes. We probably will. Okay, thanks for watching, and I'll see you in the next one. But if we honestly want to explore this idea, then first we have to ask the questions of what could happen to make humans go extinct. There are several, if not many, ways this could happen. From asteroid impacts, nuclear wars, supervolcano eruptions, disease outbreaks, gamma ray bursts, all the way to a nanobot zombie apocalypse. Oh yeah, and Judgment Day. If you believe in that kind of thing. But what if none of these catastrophic things ever happen? How could human civilization come to an end? I think that depends on one major factor, and that's based on whether or not we will ever leave Earth. If we never leave Earth and never run out of resources, then the latest we could theoretically expect to exist would be roughly the equivalent to the life of the Sun. Because when our Sun runs out of hydrogen fuel, it will expand to become a red giant and will almost occupy the space in the Sun's orbit where the Earth is now. The Sun is thought to have a life expectancy of about 10 billion years, and the Earth is around 4.5 billion years old. That means we still have about 5.5 billion years left, so that's not too bad. But what if we do leave Earth and become an interplanetary or even an interstellar species? How would we go about it? And is it even possible? With SpaceX developing the Starship, which will help us with getting much larger payloads into space, and NASA forging ahead with its Artemis program, which involves building a lunar base camp that will teach us more about the long-term effects of living on and colonizing other planets. I think it would be safe to say that we can expect to see people traveling to and even colonizing Mars within the next 30 to 50 years. But even if we are able to colonize Mars or any of the other planets or moons in our solar system, it would save us from an extinction level event on Earth, but our life expectancy would still only be that of our Sun. So what if we leave our solar system? The closest known potential planet or exoplanet that exists within the habitable or Goldilocks zone from its star is known as Proxima b, which orbits around the star Proxima Centauri. And it just so happens to be right next door to us. If you consider 4.2 light years or 2.8 billion miles away to be next door, it's hard to even imagine something that far away. The Parker Solar Probe is the fastest man-made object ever created. With the help of the sun's gravity, it was able to achieve speeds of up to 430,000 miles per hour. And that is extremely fast. But even at that speed, it would take around 6,700 years to reach Proxima b. And that's longer than written human history. For it to even be possible, we would need some sort of advanced warp drive, the ability to travel through wormholes, or a generation ship. A generation ship, or generation starship, is a hypothetical type of interstellar arc that travels at sublight speed. Such a ship would take hundreds or even thousands of years to reach nearby stars. The original occupants of the ship would grow old and die, leaving their descendants to continue traveling. Also, the ship would have to be entirely self-sustaining, providing energy, food, air, and water for everyone on board. It also has to have extraordinarily reliable systems that can be maintained by the ship's inhabitants over long periods of time. This would require testing whether or not thousands of humans could survive on their own before sending them beyond their reach of help. Small artificial closed ecosystems, such as the Biosphere 2, have been built in an attempt to work out the engineering difficulties in such a system, with mixed results. Wormholes are an even bigger problem. According to Einstein's theory of general relativity, mass and energy warp the fabric of space-time, and a special configuration of matter and energy allows the formation of a tunnel, a shortcut between two otherwise distant portions of the universe. Unfortunately, even on paper, wormholes are incredibly unstable, and even a single photon passing through the wormhole would trigger a catastrophic cascade that rips the wormhole apart. For this to work, you would need a type of exotic matter known as negative mass that could counteract the destabilizing effects of regular matter trying to pass through the wormhole, making it traversable. And there is an idea for a faster-than-light warp drive known as the Alcubierre drive. The Alcubierre warp drive is a speculative warp drive idea based on a solution of Einstein's field equations in general relativity, by which a spacecraft could achieve apparent faster-than-light travel if a configurable energy density field lower than that of a vacuum, that is, negative mass, could be created. Rather than exceeding the speed of light within a local reference frame, a spacecraft would travel distances by contracting space in front of it and expanding space behind it, resulting in effective faster-than-light travel. Objects cannot accelerate to the speed of light within normal spacetime. Instead, the Alcubierre drive shifts space around an object so that the object would arrive at its destination more quickly than light would in normal space, without breaking any physical laws. Although the metric proposed by Alcubierre is consistent with the Einstein field equations, construction of such a drive is not possible. The proposed mechanism of the Alcubierre drive implies a negative energy density and therefore requires exotic matter or negative mass. And that's a very big problem, because negative mass doesn't exist. But who knows? Maybe in the distant future we will evolve and our understanding of the universe and physics will change, and we will be able to travel and colonize beyond our solar system or even planets and other galaxies. But even then, in around 200 billion years, based on measurements of the rate of expansion and the mass density, the universe will continue to expand, resulting in the Big Freeze, where the universe becomes so vast that supplies of gas would spread so thin that no new stars can form. And without getting into theoretical quantum mechanics and multiverses, let's just say the answer to will humans ever go extinct is yes. Probably. But technically so will everything else. So thanks for watching. I hope I could help shed some light on this question. And if you enjoyed this video, hit that thumbs up, and if you want to see more videos like this in the future, then hit those subscribe and bell icons and comment below if you have any ideas for future videos you'd like to see. And I'll see you in the next one.